Hi guys, it's one and only favorite best teacher. So we are continuing with the lesson. So as you can follow the previous videos where I was explaining some of the important concepts with regards to projectile motion. So here we'll be basically doing number 8, right? So number 8, they're saying use the velocity versus time graph in question number 5 to determine the acceleration of the ball for its complete motion and draw the corresponding acceleration versus time graph, right? So one thing that you need to understand based on the previous results that we actually had, now let's draw the acceleration time graph and determine what? And determine the acceleration. So as we are determining the acceleration time graph and determining the acceleration, it means to say this is what we are going to have. So this is our graph, the normal graph that we normally use, right? And then remember that is going to be 0. And then here, because this is an acceleration time graph, let me just write here. So that is the acceleration. So that is the acceleration time graph. So since this is an acceleration time graph, it simply means to say on the x-axis, we're going to have time in seconds, right? So here we're going to have time. That is going to be in seconds. And don't forget that this time, since it's in seconds, as we are working with our graph, we actually had what? We actually had this being 1,53, if you still remember. That was 1,53. And this one was around 3,06. 3,06. So for you to be able to understand how I did get this, make sure that you follow the previous lessons, then you continue from there. And then remember, since this is an acceleration time graph, it will be a straight line graph, right? So since this is a straight line graph, here, let me just define this so that you can be able to see. Remember, that was 1,3, 1,53. So it simply means to say that is the upward movement. This one, this part, that is the upward movement. And then this one on the other side is downwards movement. So that is downwards. So this basically for you to interpret it from 0 to 1,53, that's when actually the ball was being projected to the upside, right? And then from 1,53 to 3,06, that's when the ball is being projected to where the ball is coming back from the original point of projection, right? And then after that, now this is basically where this is very important, right? So they said determine the acceleration. So now we're going to determine the acceleration, right? And then we all know that when we speak about acceleration, it's equals to what? The gradient. So acceleration is equals to gradient from t equals to 0, t equals to 0, up until where? To t equals to 1 second. So since now we're dealing with the acceleration time graph, we know that the formula for acceleration is equals to what? Change in velocity over change in time. So this is the acceleration formula that you must remember this. This formula is very important for exam purposes. So acceleration is always be given as change in v over what? Change in t. Not forgetting that when you speak about change in v, this is one, it's the same thing with you saying v final minus v initial divided by time final minus by t initial. So this it's one of the very important formulas that you must remember grade 12s, this one, for determining acceleration, right? So now it means to say we are going to determine the acceleration. So we're going to say acceleration is equals to our final velocity. Remember, it was negative 15 because I told you that when we're choosing direction, remember, let me remind you. So this is downwards. So down, we consider it as what? As negative. And then up, we consider it as what? As positive. Right? So it simply means to say our v final, it was negative 50 because it was 15 meters per second to the downwards. Hence, I told you that down is negative. So it was negative 15, and then minus the initial velocity, if you still remember, based on the previous lesson, it was what? It was 15 meters per second, right? Then we divide by what? you divide by the time final or the changing time. So the entire time, changing time is this one here, 3,06, right? So you can actually consider writing 3,06, 3,06 seconds. Then from here, guys, don't forget, because we all know that acceleration is equals to, so negative 15 minus 15, that should give you negative 30 all over what? Over 3,06 seconds. 3,06. Therefore, acceleration is equals to, then you take your calculator, let's now punch. So that is going to be negative 30 divided by what? 3,06. So we are getting negative 9.8. Negative 9.8. So I'm happy seeing negative 9.8 because it's acceleration again. These are units for acceleration, guys. It's what? It's meters per second squared. So here you're going to write meters per second squared. Taking in consideration that you can conclude to say, therefore, acceleration is equals to 9.8 meters per second squared. Negative, you consider it's what? As downward, right? So you can actually write downwards. As easy as that. So this is how basically we work with this, right? So we know that this is exactly the same as the gravitational acceleration because g is equals to 9.8, if you still remember, meters per second to the downside. So this basically means to say, since they said determine the acceleration, this is basically what we are going to do. And then you must remember that the formula for what we call for the acceleration is this one, is given by changing v over changing t. And then from here, this basically means to say you determine the acceleration, right? And then this will be our acceleration time graph, this one right here. So that's how basically we're gonna solve this, guys. It's a one and only favorite physics teacher. Subscribe and stay tuned for more.